Welcome back. Smart meters are electricity meters that don't have to be read by a person. Instead, they wirelessly send the information directly to your supplier. Your bill then shows how much electricity you used and when, making it easier to control your energy use. Old technology meters require someone to regularly read your meter. Smart meters can report consumption in real time by wireless transmission. Inside the smart meter are 3 different electronic circuit boards, the brains of the unit. They're built on large blank fiberglass panels. One panel yields 6 or 7 identical circuit boards, depending on the meter model. In the first machine, for tracking purposes, a laser etches a serial number for each future circuit board. The next machine applies a stencil in the pattern of the components to be mounted on the board, then spreads solder in paste form across it. The board now has solder paste, shaped and positioned exactly to receive the upcoming components. The next machine's 2 lasers verify that the solder paste application is perfect. Depending on the size of a specific circuit board component, there can be anywhere from 5 to 20,000 of them stored on a tape reel. Workers mount the reel for each component on what's known as the pick and place machine. This computer-controlled high-speed device picks the required parts off each reel and then places them in their designated solder-pasted position on the board. Bulkier components are stored on a different size reel, which workers mount on another type of pick-and-place machine. It does the same operation as the previous one, only slower, due to the larger size components. The boards now travel through a soldering oven. The precision-controlled temperature, peaking at 242 degrees Celsius, melts, then cools the solder paste, fusing all the components to the board. Next, each board undergoes testing. This machine applies electricity to ensure each and every component meets specifications. When the board gets the all clear, it moves to the next machine, which cuts it into separate circuit boards. Meanwhile, robots assemble the meter's digital display. They take a plastic half-circle housing and install a liquid crystal display into its rectangular window. At the next station, a robot uses a vision system to attach a circuit board to the liquid crystal display. Assembling the meter body begins with a plastic base plate. The first station prints a serial number on the bottom. The next station then flips the base plate upright and installs the components of the remote disconnect switch. This switch enables the electricity company to switch power on and off from any location. A switch cover closes up the base. The protruding wire will connect to a circuit board. The next station installs 2 terminals through the switch cover. These function as part of the switch operation, as well as part of the meter's measurement of electricity consumed. Once those terminals are in, an automatic screwdriver secures the switch cover. Now, the first of 3 circuit boards. This one, the metrology board, measures energy consumption. The unit comes off the automated line and a worker completes the assembly. He attaches a connector to the digital display's circuit board, installs the display, then connects the switch wire to the display's board. The metrology board sends its measurements to the display circuit board, which interprets the data and sends it to a third circuit board, which transmits it by radio frequency to the utility. Once workers have fully assembled the housing, they install a metal tamper evidence seal. Every meter undergoes rigorous final testing. An automated station verifies the display using a vision system. It checks that the meter measures electricity accurately and successfully transmits and receives messages. So fiddling the meter is a thing of the past.